7.5 might be one of my favorite sections, not subjects, because it's putting it all together. Everything we've worked so hard for is how are we going to solve this? So there's actually two ways that we can solve these problems. First, if I find a common base, I can rewrite 16. 16 is the same thing as 2 raised to the 4th power. I can also rewrite 8. 8 is the same thing as 2 raised to the 3rd power. Right here, I can use my properties of exponents. Power to a power, I would multiply. So this becomes 2 raised to the 12x, 3 times 4, is equal to 2 to the 3rd. Whenever you have an equation and the bases are the exact same, that means these exponents have to be the exact same. So I could actually write the equation 12x is equal to 3. So now to solve for x, I would divide by 12. I'm going to get 1/4. X would be equal to 1, that's a 4 there. Next section, or next one, if I want to change my base. 27 is the same thing as 3 cubed. So I'm just rewriting the 27. 81 is the same thing as 3 to the 4th. Here, this power to a power would multiply, and I would get 9x. So now I can do 9x has to be equal to 4 in order for those to be the same. So x is equal to 9/4. And by 9/4, I mean 4/9, because I'm dividing by 9, 4/9. Try to do the next one by yourself. So 2 to the x would be equal to 2 to the 4th. 16 is 2 to the 4th, so x would have to be equal to 4. Now, that's not always going to be the case. We're not always going to have the option to rewrite these problems. Sometimes you might have to solve it without redoing the base. And this is the way I personally like to solve the problems. Whatever your base is here, the inverse of an exponential base would be a log base. So you can do log base 15 on this side. And whatever you do to one side, you have to do to the other side. So I'm still going to do log base 15. When this happens, when your exponential base and your log base are the same, so exponential base, log base are the same, those would simplify just to be the 3x, because log base 15 of 15 is going to be equal to 1. So this would just be a 3x on this side. I'm going to keep this as log base 15 of 285. Now to get my x by itself, I'm going to divide this whole thing by 3. So x would be equal to, when I plug this into my calculator, I'm going to go to math, go to my log base, 15, 285, make sure to arrow over that whole thing. Look how that parentheses just around the 285 divided by 3. My answer will be 0.695, and the 6 will round the 7 up to 8. So that would be my final answer. For the second one, if I look at this, my base here is 5. I have a base, an exponential base of 5, so I can go log base 5 on one side be equal to log base 5 on the other side. Because again, as long as these two match, they will cancel each other out, and I would have 2x. I'm going to leave that log base 5 of 130 and divide by 2. Try to do that in your calculator. And you should have got 1.5122. Try to do the next one by yourself. So you should do log base 2 on both sides. Now I want to get this x by itself. So the first thing I'm going to do is add over my 4. Notice how I'm not actually going to put in my calculator yet, because this will be a decimal. You should put it in your calculator at the very end. This whole thing should get divided by 3, because I want to get rid of that multiply. So I type this into my calculator. I'm going to go math, log base 2 of 5. I personally like to do it this way. So I'm going to add the 4 and then push enter, divide by 3. So x will be equal to 2.1073. So in this next section, what if we want to try to solve it using a table or a graph? So what we can do in our calculator, looking at this one, go into your y equals 4 raised to the 3x. Then I want to have it be equal to 6,000. Now, if I push graph, probably I'm not going to be able to see the 6,000 because this only goes up to 10. So what I have to do is I'm going to go to my window, and I'm going to put my maximum for my y, because I want to get up high. I want to see what's happening way up there. For my y max, I'm going to put 7,000 in graph. And hopefully I will see them both on this graph. So there's my equation, and then there's my 6,000. So again, the equation, and then just what is equal to 6,000. I can find that intersection right there. I can go to this calculate. If I go second key and then trace to get to calculate, we can go to intersect. It says the first group. You can move these arrows over, well, left and right. So it's saying the first curve. So what's the first equation you want to look at here? The second curve. So that's this line back and forth. Enter. And now it's saying try to guess at the point you want us to look at. So I would say this right here would be the guess. You can move that all around. The intersection would be x would be equal to 2.0918. So if you look again, your x value is right there. There we go. So write down, this would be 2.0918. So I'm going to help you again, just remind you, you put your two things in your calculator. So I can go 7 raised to the 4x. And on the second one, I'm going to put 800. I'm going to go back to my window because I do not have to be that high up. And I'm going to go my y max. So I went to window. I'm looking at my y max. I'm going to set that to 1,000. Graph. So it should pop up here, and then you should try to find the intersection by yourself. There it is. So push pause, try to find it by yourself. So you should have went second, calculate, intersect. It's saying first curve. Again, you can move left and right. Here's my first curve, enter. Second curve, my second graph, really, and then my guess, so about right there. You should have got 0.8588. 0.8588. Be aware that you could also do this mathematically like we just did above. Try to do the next one by yourself. You should have got 1.211 and then rounded to 4 right there. So one thing, when you're doing it on your calculator, this is a great way to check your work, to check to see if you're getting the same answer. However, I do want to see it mathematically. So if you don't have any work shown for problems where I'm asking to solve, then you're not going to give any points for me. So looking at this question, wood is sustainable, renewable, and natural resource when you manage forest properly. Your lumber company has 1,200,000 trees, and you plan to harvest 7% each year, so you're increasing it. How many years will it take to harvest half of the tree? So we've already actually had problems like this in 7.1, I believe. So my starting value was here, and my rate would be, again, I'd move it over 2 to the left, so 0.07. It's asking for how much time. How many years will it take to harvest? First, you have to kind of understand the situation. So it's saying harvest half. So there's this many trees out there planted. And each year they're going to try to take 7% of the amount of trees that are already planted and take them down. Okay. So it's asking how long will it take to harvest half. So we want to figure out half of 1 million would be 600,000. Okay. This is what we're getting to. So if we start at 1,200,000, my rate here, I'm decreasing by 7% each time. Each year, I'm taking away 7%. So that's my percent decrease. It's asking when will this be 600? In 7.1, we used our equation in our calculator. But now we have enough so that we can actually solve it mathematically. So first thing I'm going to do is divide by 1,200,000. And again, if we wrote this number correctly, it should be half. which it is. I'm going to also do 1 subtract 0.07, so that's going to be 0.93. And this is 1/2. So now my base here is 0.93, so I'm going to go log base 0.93, log base 0.93. These two will cancel out with just t. That will tell me my time. My calculator is good. I'm going to go to math, arrow up, log base 0.93 of 1/2. So it'd be 9.5513 years. And I would prefer you to leave it like this. You're not going to round, you're going to actually put down the decimal. So after how many years will you have harvested half of the trees if you harvest 5% instead of 7%? I want you to try to do this by yourself. The only thing that's changing between these two is that rate. Try to do it by yourself. Should have gotten 13.5134 years. So obviously, because the rate is smaller here, your decreasing rate is smaller, it's going to take longer to harvest those trees. So logarithm equations, last two questions. All right, we're going to solve the equation. In these two equations, we actually still only have one log. However, we can still, we want to do the opposite of the log. So the other problems, we were given the exponent, but we had to solve using the inverse with the log. Now we have the log, but we have to solve the inverse of the exponent. If there's no base given, remember that's always going to be a base 10. Again, log base 10, the inverse would be an exponential base 10. So I could rewrite this as 10 raised to log of 4x minus 3. Whatever you do to the one side, you have to do the other side. When you have an exponential base with a log base, like here, again, there's no 10, there's always one shown. Those two cancel each other out, leaving you with 4x minus 3. And then you can do 10 squared. Again, this is an exponent. Whatever it was equal to becomes your exponent, which is 100. So I can add over my 3 and divide by 4. And I get x would be equal to 25.75. Again, you're doing the inverse. So looking here, my base here is 10. So the inverse of log base 10 is exponential base 10. So taking the whole equation and then actually making the whole equation into an exponent. These two cancel each other out, leaving you with 3 minus 2x. 10 to the negative 1 is 0.1. And then you're going to add over the 3. So negative 2x, that subtraction stays with that 2, is equal to 3.1 divided by negative 2. So x is going to be equal to negative 1.55. And there you have it. One step closer to becoming the genius you are in Chapter 7. Have a great day.